4? Sure, you got it. All right, so problem number 4. So we have a parabola that basically does this. And it appears that -1 comma 4 is the vertex. So I'm just going to list kind of the important things. Or -1 positive 4, excuse me. And it looks like it's crossing here at 1, 0, and it's crossing here at -3, 0. And I realize I don't have the XY axis, but that's for the most part what it looks like. Agree? So the first one says, hey, what is the domain? Well, what's the domain on all of these? Negative to positive infinity. Good. And then the range is where it starts getting silly. Okay? So think about what this graph's doing. It's pointing downward. Okay? Range always comes bottom to top. So being it's pointing downward, our range is coming from negative infinity, because that's way down low. Negative infinity is way down there. And it's an elevator riding up all the way up to 4. What kind of bracket's on the 4? It's a hard bracket. And it's a hard bracket because that point exists on the graph. Okay, there are times you will deal with a range where you'll have a soft bracket, but not on the parabolas. Okay? Does that make sense? And yes, I am looking to make sure you have the brackets right. Okay, so each of those, the domain would be a point. The range would probably be 2 points because I'd be looking to make sure you have the range right and you have the hard bracket. The infinities, and we'll never have a hard bracket on them, okay? All right, letter C, we have max. And a max is when the parabola looks like this. Or we have min, that's where the parabola opens up. So do we have a max or a min on this one? We have a max. What is our maximum y value? 4. Okay? That's all you have to put. D asks for the roots. The roots deal with when you have a 0 in the y spot. So my roots are -3 comma 0 and 1 comma 0. Well, if you could have 1, 0 and -3, 0, that's totally fine. Just don't have 0, -3, because that's a different point, right? Yeah. Letter E. Letter E should be pretty straightforward. They're looking for the vertex. The vertex is at -1 comma 4. And then letter F says the axis of symmetry, which we'll call AOS. The axis of symmetry is always x equals the x component of the vertex. And then letter G. This is where things start getting a little newer. Where is this increasing? So remember, we said increasing means it's doing an up, right motion. So upright, 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 upright. So it's increasing from negative infinity all the way up to the x component of the vertex to -1. What kind of bracket is on the -1? It's soft. Because right exactly at -1, it's no longer increasing, but it's not decreasing yet. Okay? So it's important to have those down. That'll help you later in math. E, F, G, H. Interval where this thing is positive. Positive. Okay, spell it right now. There's a T there. Positive. So positive basically means here's my x-axis. It's anything above here is positive. So it is positive from -3 to 1. Notice I didn't have any infinities on that one. Okay? So if the parabola opened upward, that's where you incorporate the infinities. But we're going from here, from this point exactly right here, to this point exactly right here. That region in between is where it's positive. Those are both soft brackets because right exactly at -3 and at 1, it's at 0, and 0 is not positive or negative. Now, where sometimes this might get confusing, this is not a point. Okay, a lot of people think, oh, at -3 comma 1, it's positive. That's not a point. This is called interval notation, with soft brackets to indicate that you don't include exactly those points. Okay? What else did you see that I can help you with? Yeah.
Wait, so for G,
G.
Would it not be negative infinity to 4? Because that's
Oh,
y.
okay. So when you're talking about increasing and decreasing, you use the domain, which are the x values, to indicate where it would be growing.
Okay.
So this is, here's your calculus lesson for the day. XY axis, still with me? I'm just going to draw in a parabola. Okay. So remember back in the day when we find a slope, m equals y2 minus y1 over x2 minus x1. So this this was the equation. The slope equation's this, right? So what that means is I have an infinite amount of points on this line. So in the world of calculus, if you wanted to take something called a tangent line is a line that touches a shape exactly one spot. So these are tangent lines. So what if I found the slope of these tangent lines, these slopes of those green fancy looking things, those slopes would be positive. As soon as you got to a tangent line of right here, get to a tangent line right here where it's a horizontal line, that has a slope of 0. And then if we change our tangent line to go this way, these then, as they kiss the graph once, these all have a slope of a negative number. But what you're basically finding when you're doing the slope, if you took an exact value of an x value, it has something called the instantaneous slope, and that just means there's a linear equation that the parabola kisses once. So a tangent line touches it once. So that's the long and short. So this is a couple years away from doing, but it still works very well. Does that make sense?
Yeah.
All right. What else could I help you with on any of those problems?
Number 6.
6? Yeah. All right. Number 6. We have a graph that kind of looks like this. And it looks like 1, 2, 3. This is like the point 3 comma 0. This point here looks like the point 5 comma 0. And this looks like 4, negative 1 maybe. Okay. And so basically I have that's my x-axis. I'm not worried about the y-axis on these. All right, so domain is negative to positive infinity. So that's always the same. The range is our lowest value in the y direction, so negative 1, and it opens up, goes to infinity. Okay, this is where our range starts. Okay, again, we're looking for that hard bracket. Do we have a max versus a min? We have a min, and our min is happening at negative 1. Okay, this is my lowest point. That's my min. Okay, you look for the y component for the min. The letter D, the roots, you have 3, 0, and you have 5, 0. Vertex, we should be able to identify. 4, negative 1 is the vertex. F, axis of symmetry. AOS is x equals the x part of the vertex. And then G, where is this increasing? So it's increasing here. So it starts increasing at 4, okay, but it's a soft bracket, so we don't include it, and we'll continue to increase till we get to infinity. And then where is this positive? Positive means it's above the x-axis. So this region here, all right here, is above the x-axis. Okay, so on that, this is going to look a little different than the last one because I go from negative infinity to 3, and then I also go from 5 to infinity. Okay, so that's that one. good? Happy? Content? All right. No more questions? We're good? All right. Will you go to page 91, 91 of your notes? So we've already been doing this. So this is just a review of what we've been working on. Okay? So this is just a review of what we've been working on. So notice they say slopes will be. Okay? Basically, the main thing I want you to realize with the 135 rule, it's always going to be A times these values. Okay? And again, the 135 is just 3 odd numbers. It goes forever. It's 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. But you run out of room on your graph. So that's why we only take it out this far, because this will get us enough information. Realize I want this written on every parabola that we do. Okay? And then I want your A value, your B value, and your C value to be written down as well. Trust me, this will help you in future stuff. If you have just the simplest of that listed, it'll help you because it's going to guide you along. Okay? So, first thing I want negative b over 2a. I want my a value, my b value, and my c value. What's my a value up here? 1. B value? Negative 4. And c value? 3. And so, again, I can find my y-intercept real easy, saying just 0, c, or 0, 3. Okay, but again, where it crosses the y-axis is not the most important point in the world. You know, maybe just come to the side and say, you know, the y-intercept is at 0, c, so that's at 0, 3. Okay, and again, this point is just a point that sometimes our pattern graphing will find right away, but it might not. So, but that's just a point that exists on our graph, and that should be relatively simple. And then I'm going to use negative b over 2a, so I'm going to go negative 4 over 2 times 1. Negative 4 is positive 4. 2 times 1 is 2. So I'm going to get 2. So that's my axis of symmetry, is x equals 2. So my axis of symmetry at x equals 2 is right here. Okay, now, I heard this term the other day, and I thought this was kind of creative. The axis of symmetry is the street. Like the road you live on, the street you live on. Make sense? The vertex is actually the address to the home that you want to be at. I don't know whether it works for you or not. So how do I find the vertex once I know that I have 2 comma something? What should I do with the 2? Plug it in for x. So I'm going to get y equals, where those parentheses are is where x used to be. Now I'm going to plug 2 in. Order of operations, 2 squared is 4. Negative 4 times 2 is negative 8. And then plus 3. 4 subtract 8 is negative 4. Negative 4 plus 3 is negative 1. So I have a vertex at 2, negative 1, which is right here. Seem okay so far? Now we're going to pattern graph. So I have a times 135. What's my a value? 1. So it's 1 times 135. So the math that takes place on that, I would distribute 1 over, so I still get that. All right, so talk to me. How do I pattern graph from the vertex? So it's the very first move. Right 1, up 1, and left 1, up 1. Okay? Now, those points there are important. Why are those important right now as they sit? They are roots. How do you know the roots? You are totally correct, but how can you guarantee 2 ways they're roots? It's on the dots are right on the x-intercept. They're like that, and the zeros in the y. That's exactly right. Okay. So now, if I want to graph a little bit further, now I'm going to use the 3. So how should I generate the next set of points? Yeah, from the burgundy points, I'm going to go right 1 up 3, and I'll go left 1 up 3. And look at that. that blue dot happened to fit right there with our new dot. So the pattern graph worked for it. But this is my parabola. Okay. It looks like I probably could have graphed the 5s as well because our graph, it would have fit on our graph. But I think if you have those 4 points labeled and you realize, oh, okay, so 1, 2, 3, 4, and you have these points labeled, you have a lot of information you've labeled. And it's not difficult as long as you have a grid. When you're trying to draw your own XY axis and you have your piece of paper that's balancing on top of your phone and you have 3 pencils underneath it and you're trying to draw straight lines, it doesn't work real well. But that's kind of a reality of it. Okay, are we all right so far? So this is definitely stuff we've seen. Agree? This is not, shouldn't be brand new. We've been talking about the 135, but it's a really important skill. It's going to go with you. So we know our roots. They're there. Our roots are here and here. We know the y-intercept. We called that right there. We know the vertex. That was right there. We have everything we could ever possibly want about this parabola. Cool. May I move on? Is there one more slide? That's it? One problem left? Sweet for a Friday. Okay. You talk to me. What should I put first? Negative b over 2a. Agree? Hey. What was it? 88, 89, 90? Or 87, 88, 89? It was finishing the one from the other night.
Only 1 and 2.
Well, we did 1 and 2. Now you're going to do all the rest of the problems. Cool. Good seeing you. All right. What's next? A, B, and C. What's A? B? C? Negative 9. Okay. Let's do the y-intercept just because we can. 0, comma C. So what's the y-intercept, friends? Thank you for making a point. Appreciate that. 0, comma negative 9. So 0, comma negative 9 is down here. And again, that does not always become a real important point for us. It's just another point that exists. Our pattern graph might fall on it, which is great, but it might not, and that's okay. Okay? All right, so what's next? Negative b over 2a. I like it. So I get negative 12 over negative 6, which is positive 2. Okay. So that's our axis of symmetry. Agree? The axis of symmetry is always x equals a number. X equals a number is a vertical line. Is the axis of symmetry necessarily part of the graph? No, it's just a guide. What lives on that pink dotted line? Vertex. Okay, how do I find my vertex? What so far do I know about the vertex? 2, yeah. So how do I find the rest of my vertex if I know the x value being 2? Plug it in. So I get y equals negative 3 parentheses 2 plus 12 parentheses minus 9. What used to live in those parentheses? X. What's going to live there now? 2. All right. So 2 squared is 4 times negative 3 plus 24 minus 9. So that's negative 12 plus 24 minus 9. So negative 12 added to 24 is 12. Minus 9 is 3. So at 2, 3 is my vertex. Okay. Hey, does it make sense right now that this graph is opening downward? Yeah, you know your vertex, and you happen to know a second point being the y-intercept, so it should be obvious that this graph is going to open downward. All right, I'm going to pattern graph. So it's a times 135. What's my a value? Negative 3. So I need to multiply that negative 3 by all those. So I'm going to get negative 3, negative 9, negative 15, which is probably going to grow off our graph pretty quickly. So how do I satisfy this negative 3? What should I do? From where? from the vertex. Right one down 3. Left one down 3. What did those just find us? Yeah, they found us some roots. Okay, how do we know the roots? They cross the x-axis, making a point on the x-axis. They also have y values that are 0. Okay, I think I can pattern graph one more. I think I can plug the 9 in. So I'm going to go for my blue dot. I'm going to go left 1 down 9. Oh, lo and behold, that's the same point. And then right 1 down 9. So it looks like the point 4 comma negative 9. Do we have enough information to get a picture here? I think so. There's our parabola. We have an awful lot of points that we've established. Okay? Not too bad. So we're focusing on this quite a bit. Now, things just to know of reasons we had done in the past. So our factoring that we had done, remember we set the factoring equal to 0 and you found like x equals 3 and x equals 4? That's where it's crossing the x-axis. So the factoring goes along with this type of stuff with the parabolas. It finds us the roots. Okay? Do we always know the roots? No. Does it cross the x-axis and it doesn't land on an exact point that we found? Yes. And that's okay. A lot of times that just means that either our pattern graph didn't pattern graph far enough, our pattern graph went right past it, which means that it would solve, but it's going to be like some decimal that never repeats. Okay? So it's called an irrational answer. Okay? But this is everything from the 135. We've worked on this. And I would like us for Monday. You guys want a lot of homework? Good. All right. So page 93 and 94, and I'll give you a break. 94 is blank. So just do problems 1 through 6. They're all pattern graphing. Remember, I want to see this with every problem. Trust me, my friends, by you creating this habit now, this will live with you and be a good thing. Okay? Giddy up.